All right, so the previous ones we were finding the scale factor if it existed and saying if they were similar or were not similar. In the next part, we're going to know that they're similar, and what we're going to be doing is either finding the scale factor or finding the surface area um, ratio or the volume ratio, whatever that may be. Okay, so with the scale factor, we're just going to say that the scale factor is A to B. So this is just going to hold the place of some number. So it could be like 5 to 4 or something like that. So, oops. So it could be like 5 to 4, whatever it may be. Now, and also this can be written as A over B. If you like that form better, that's fine. So for surface area, the scale factor, so the surface area ratio that we're going to use, we take that scale factor, but we square both of the values. Because I think about it as like area is squared. So it's going to be A squared to B squared, okay? Which can also be written as A squared over B squared. So think about like surface area. Area is square units, so is the ratio. Volume, it's going to be, since volume is in cubed units, so it's going to be cubed. All right, that scale factor is going to be cubed. So it's going to be A cubed to B cubed. Now, all we're doing is we're taking that scale factor and we are just cubing both of the values. Same thing for surface area. We're just squaring both of the values. So those values are changing because we're cubing and we're squaring them. That's it. So for this first one, number 4 here, we're identifying the scale factor and finding each scale factor such ratios for each pair of similar solids. So the scale factor for this one. So this is, we know they're similar, so we just have to pick two corresponding sides in this one. So it doesn't matter. We can pick any of them. I see a 10 here. That's a nice number. See a 5 over here. There we go. We know they're similar, so we just have to pick two matching sides or two corresponding sides. So if we do 10 over 5, that reduces down to 2 over 1. Okay? So our scale factor here is 2 to 1 or 2 over 1. Now, what we do for surface area is we're going to square them, okay? So we're going to take both values and we're going to square them. So for surface area, come over here, it's basically saying 2 squared to 1 squared. Well, we're going to put that in our calculator and see what we get. So surface area ratio, if we do 2 squared, we're going to get 4. If we do 1 squared, we're just going to get 1, okay? So it's 4 to 1 or just 4 over 1. For volume, we're going back to the scale factor, okay? Back to the scale factor. We know the scale factor is, so don't use the surface area ratio, okay? Use the scale factor that we found. So the scale factor was 2 to 1, but this time it's volume. Volume's in cube units. Same thing. We're going to cube those two numbers. Well, 2 cubed, all right, 2 to the third power is going to be 8. 1 to the third power is just going to stay as 1. All right. So make sure when you're doing these, guys, find the scale factor. Find this first, okay? So find this first. That is the most important part, that you find that first, and then you work off of that to find the surface area and to also find the volume ratio. All right. So moving on to number 5 here. Again, we have to find the corresponding sides. We know they're similar. And guys, for this, if I see 10.5, I'm going to avoid that one because decimals, I don't like them. That's not going to be too good. So I'm going to use the 4 and the 6, which is the radii of those cones. So 4 over 6, well, that reduces down to 2 over 3. So the scale factor is 2 to 3. All right. So from there, or we could write it as 2 over 3, whatever. Either one's fine. So